Chapter 7, Right Triangle Trigonometry. Lesson 7.1, Apply the Pythagorean Theorem. You already know the Pythagorean Theorem. A squared plus b squared equals c squared, where a and b are the lengths of the legs, and c is the hypotenuse. But this only works if it's a right triangle, such as this right triangle. In this right triangle, the legs are x and 3, so those are the a and the b. And the hypotenuse, which is opposite the right angle, is c. So I can go a squared plus b squared equals c squared. A is the x, b is the 3, c is the 5. 3 squared is 9, 5 squared is 25. Subtract the 9, x squared is 16. Square root, x is 4. Let's try another one. On this one, the legs are the 4 and the 6. The hypotenuse is the x, it's the longest side opposite the right angle. So I can go a squared plus b squared equals c squared. So that'd be 4 squared plus 6 squared equals x squared. That's 16 plus 36. So that's 52 equals the x squared. So to solve for x, I need a square root. So to simplify the square root, think what times what makes 52? See, 52 is 4 times 13. I want one of those numbers to be a perfect square. 4 is a perfect square because the square root of 4 is 2. So x is 2 times the square root of 13. We call that radical form. The top of a ladder rests against a wall 23 feet above the ground. The base of the ladder is 6 feet away from the wall. What is the length of the ladder? So maybe we want to draw a picture first. Let's assume the wall and the ground are perpendicular. The ladder is leaning against the wall 23 feet up. The base is 6 feet away. We want to know the length of the ladder. X in this case is the hypotenuse, so my sides, the legs, are a and b, the 6 and the 23. Make sure the hypotenuse is always the c. A is 6, b is 23, x is c. So 6 squared is 36. 23 squared is 529. 36 plus 529 is 565. So for x, you have to square root. So I think what times what makes 565, one of which is a perfect square. And the only thing I can come up with is 5 times 113, but neither of those are perfect squares. So the square root of 565 is the radical form. But word problems often want decimal form. So let's go ahead and get decimal form. Punch it in the calculator. Get 23.77. That's decimal form, or rounded to 2 decimal places. If your calculator is only giving you the square root of 565, because it's like my scientific calculator, look for the button like that. It is right above the enter button. Anyway, that one there, that will give you the decimal form if you are in radical form. All right, let's try something else. Oh, let's find the area of a triangle. All right, area of a triangle is 1/2 base times height. Well, there's the height. I don't know what it is. I do notice my triangle is isosceles, so I could split it into 15 and 15. The base could be split in half because the height or the altitude is also a perpendicular bisector. Then I can use this yellow triangle and the Pythagorean theorem since it's a right triangle. So I can say a squared plus b squared equals c squared. The legs are h and 15. The hypotenuse is the 18. So a could be h, b could be 15, and c has to be 18 because it's the hypotenuse. 15 squared is 225. 18 squared is 324. Subtract the 225 and you get 99. Square root to find h, and let's go ahead and do radical form. So what times what makes 99? One of which needs to be a perfect square. That's right, it's 9 times 11. Square root of 9 is 3. Square root of 11. So that's the height. So now let's find the area. Area is 1/2 base times height. The base would be the whole base, whole side of the triangle, 30. The height is perpendicular to the base. We found that to be 3 square root of 11. 1/2 of 30 is 15, times 3 is 45, square root of 11 feet squared. And again, that is radical form, which is exact. We haven't rounded anything. Or we can type it in the calculator, get 149.2, which is decimal form, or in this case, rounded to the nearest tenth, or rounded to 1 decimal place. Let's try another one. Again, this is an isosceles triangle, so our base can be divided into the 10 and 10. Want to find the height, so I can use the yellow triangle. In this triangle, the hypotenuse is 26. So I can say a squared plus b squared equals c squared. A could be the h, b could be the 10, and c has to be the 26, the hypotenuse. 10 squared is 100. 26 squared is 676. Subtract the 100, and h squared then would be 576. Square root that, h is 24. Since it comes out exactly to be 24, we call that an integer, and it's special. It's also radical form and decimal form in the same number. Let's find the area. The base is here. It's the side of the triangle, so it's 20. The height is perpendicular to the base, which we found to be 24. Half of 20 is 10, times 24 is 240. The units are meters squared. And again, since that's exact, it could be radical form and decimal form. We have a special name for these numbers in a Pythagorean theorem that are all integers, all exact with no decimal places. We call them a Pythagorean triple, which is a set of 3 positive integers that satisfy the Pythagorean theorem. Your book is the long list. We have these ones in bold: 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25. Those are heads of families of Pythagorean triples. If I take the head, such as 3, 4, 5, and I multiply it by 2, I get 6, 8, 10, which is also a Pythagorean triple. If I take 3, 4, 5 and multiply it by 3, I get 9, 12, 15, which is also a Pythagorean triple. If I take 3, 4, 5 and multiply by 10, I get 30, 40, 50, which is also a Pythagorean triple. So if you take any head, any Pythagorean triple, and you multiply them all by the same number, you get another Pythagorean triple. And these can be used to solve triangles, such as this one. All right, so we look at this right triangle, and we see the 9 and 12, they're the legs. And we're looking for the hypotenuse. The hypotenuse, remember, is the longest. So if we go back to our list, we want to find a Pythagorean triple as 9, 12, and then something longer. So 9, 12, and something longer. How about this one right here? 9, 12, 15. 9 and 12, and then something longer, which would be 15. Since x is the hypotenuse, x is 15 inches. Could also just use the Pythagorean theorem, of course. That's all for today. Have a good day.